Hello everyone, welcome to the third page of our notes. Today we're going to be talking about triangle similarity. So triangle similarity, it has a very strong connection to something we've already talked about, just like with congruency. We know that congruency was the situation where two triangles were identical, or two figures were identical to each other. They had the same sides, the same angles, everything was the same. Today's going to be a little bit different. For something to be similar, the sides are no longer going to be congruent to each other. The sides are going to be proportional to each other. So if the sides are proportional, you potentially have the situation where you could have two similar figures. For it to be similar, though, the angles have to be congruent. So the angles are still congruent to each other. In other words, the angle measures are preserved while the sides are proportional. So we need the angle measures to be preserved. They have to be the same angle measure. Let's talk about what I mean by that. So if I were to come over here and draw a figure, I'll just do it this way. We'll go like that. All right, so you can see I've got these two triangles right here, right? Let me go ahead and zoom in. We got these two triangles, and you can see that if I put this one on top of this one, it is exactly the same triangle. There is nothing different about them. They're identical to each other, right? So what would happen is if I took this and I shrunk it, so you can see these triangles are no longer identical. They are not congruent triangles anymore. They're what we call similar triangles, in the sense that if I took this angle and I hover it over here, see how these two angles right here are identical to each other? Or if I take this top angle and hover it over here, those two angles are identical to each other. And if I hover this one down here, these two are identical to each other. The only difference is that this triangle on the inside is smaller than the one on the outside. It has the exact same angles, but the sides are proportional. And you can see that it almost looks like it's double, right? This side looks like if I doubled it, it would reach both of them. This one over here, if I doubled it, it would reach both of them. Over here, if I doubled it, approximately, it would reach both of them. So similar has the same angles, just proportional sides. We have three ways that we can prove similarity in geometry. Three that are going to look two of them that look kind of similar to things that we've seen in the past. The first way you can prove similarity is through side similarity. SSS similarity. So what SSS similarity looks like is that all three sides are proportional to each other. So in other words, if I talked about these triangles, let me just label this up here. A, B, C. Move that over there. And we'll call this D, E, F. If those two triangles are similar to each other, to prove similarity, we'd have to prove that AB divided by DE is equal to BC divided by EF, which is equal to AC divided by DF. If I can prove, not DE, sorry, DF. If I can prove all three of those fractions come out the same, and all I did is I divided this one by this one, this one by this one, this one by this one. If I can prove that all three of those give me the same scale factor, I know that they are congruent by side similarity. The next one, again, going to be another familiar looking one, side angle side similarity. So in this case, again, you're proving two sides are proportional. So using the same thing as over here, you need to find that two of those, so maybe just these two are proportional, or maybe just these two are proportional, or maybe the first and the last are proportional. You just need to prove that two of these are the same, and then that one angle is congruent. So you need one angle to be the exact same angle, not similar, identical to the exact same number. So if one angle is 60, the other one has to be 60. And the only other one we have to prove similarity is a little bit different than ones we've seen in the past. Angle similarity, AA. So if you can prove two angles are exactly the same, you've proven that they're similar because it's angle. Technically, it's angle. We always know the third angle of a triangle has to add up to 180. So technically, it's angle. But if you have two angles, that's enough to do it. All right, determine if the following triangles are similar or not by angle, angle. So all we're doing with this first set is we're checking if angle, angle determines if they are similar to each other. So what I'm going to do is I'm going to try and see what I can figure out here. I can see that here I've got two parallel lines. So there's any zigzags that I can make would refer to similar angles. So for example, this right here, that zigzag tells me that this angle and this angle have to be the same. And I also know that this angle and this angle are vertical, so they have to be the same. So at this point, I can see that in just this triangle right here, I've got angle, angle similarity. So this one does work. All right, in part B, again, I got these parallel lines. This one has to do with our little, and just to kind of clarify, you can see the two triangles here. There's a triangle here that's this little one, and the other triangle is this big one that we're looking at. Those are our two triangles. So I can see that there are these two parallel lines. If I were to connect them here, we know that the corresponding angles would be this angle and this angle. So those two have to be the same. Likewise, I could go on the other side and do the exact same thing, right? Parallel line, parallel line. That one also creates a pair of corresponding angles. So this one and this one. So yet again, yes, these can be proven by angle, angle similarity. In part C, this time they gave me two pictures and they gave me two of the angles inside each one. So in part C, in the first one, they gave me the 90 and a 39, but I'm missing this angle over here. Over here, they gave me the 51 and the 90, but I'm missing this angle here. I do know that the 39 and the 51 do not equal each other, so this does not have angle, angle similarity yet. But what we know is we could subtract these. So take the 39 and the 90 and add them together. I get 129. And if I subtract that from 180 and get 51, meaning I know that this angle has to be 51. So now I can see I've got 51 and 51. I've got 90 and 90. So I would say, yes, these are congruent by angle, angle similarity. All right, I'm going to go ahead and leave those last three for you to try yourself. I know that we have lots of yeses there, but they are not always going to be yeses. So be mindful of that. See if you can prove that those are similar by angle, angle, or if you can find ones that are not in this case. I'm sorry. All right, objective 2 says determine the following triangles are similar by side, side, side similarity. So for this, we've got to go through and show if there are proportional relationships. So what we need to do first, we need to match up what's going to go together. So I'm going to start by just highlighting. So in this case, I can see that the 27 and the 42 are definitely going to go with each other. So my first proportion I'm going to write down here is 27 over 42. And I'm going to put an equal sign and we'll put like a question mark over it. Is it equal? And let's determine what the next one is. So the next side looks like it's the smallest one, which is the 14, and the smallest one over here is the 9. So since I did 27 over 42, I need to do 9 over 14. Keep that same pattern going. So 9 over 14 equals question mark. And that leaves us with the last one, which is the 13.5 divided by 21. So what I need to do now is I need to go check all of these and see what decimal answer I'm going to end up with. So let me break out a calculator. I know you can't see me right now, but I'm getting a calculator out. All right. So for that first one, 27 divided by 42, 27 divided by 42, if I put that in a calculator, I get 0.642. So I'm going to put 0.64. 9 divided by 14, I get 0.64 again. And last, 13.5 divided by 21, I get 0.64. So since all three of these came out to the same number, I would say yes. I want to do that in purple. I would say yes, they're congruent by side, side, side similarity. All right, taking a look at B. In this case, I've got, again, two triangles I'm focused on. This little one and this big one. The big one we have to be careful because we're going to have to add the 15 and the 6 together for this side and the 20 and the 8 together for that side. So starting by setting this up. So my first side is that we're going to compare 20 with both numbers over here. So we're going to compare it with the 20 and the 8 together. So 20 over 28. And we're going to say, is that equal? And on the other side, we're going to compare it with 15 over both of them together. So 15 plus 6 is 21. So 15 over 21. Is that equal? Question mark. The bottom's a little bit easier. It's the 40 and the 56 go together. So the smaller one over the bigger one. 40 divided by 56. All right, so checking this out. 20 divided by 28, that gives us 0.71. 15 divided by 21 gives us 0.71. 40 divided by 56 gives us 0.71. So I would say, yes, these are similar by side similarity. All right, again, I'm going to go ahead and leave those next two for you to try on your own so that you have some strong practice with this. Going on to the back side of this page, now we move in and we talk about side angle side. So a side angle side, what we're looking for is, again, that there's two proportional sides, but one angle in between them that's congruent. So in this first picture, the first thing I'm picking up is, hey, this and this are vertical. So I know that those are going to be okay. Those are going to be good. And what I need to do next is set up my proportions. And this one's a little bit hard to see, but what I can tell you is that the 24 and the 6 go together. This triangle on the bottom has been flipped backwards. And then this 12 and this 48, they have to go together. And just to kind of, I don't know how to turn something. I was hoping I could turn it, but I don't know how to do that, so we're not going to worry about it. All right, so we're going to go ahead and set that up then. I've got 6 over 24. I'm going to put the smaller number on top. Equals question mark. And again, the smaller number is 12, so we'll put 12 over 48. 6 over 24 is going to become 0.25. And 12 divided by 0.48 is also 0.625. So we would say yes. These are similar by side angle side similarity. Side angle side. For part B, again, we've got a little triangle and a big one. So you can see that with these triangles, they're sharing the same angle up here. So you can always mark this angle for side angle side. If you got two overlapping like this, this angle is always considered one that is congruent. So all I need to do then is check that the sides are proportional. So the top triangle is 15, and then the length of the whole triangle is 45. We got to ask ourselves, is it similar to? And again, we're going to do 14 on top, and then the whole thing 28. So 14 over 28. All right, so 15 divided by 45 is going to give us 0.33 repeating, and 14 divided by 28 is 0.05. So in this case, these two numbers came up completely different, so we would say not similar. And for C, we have this shape right here, these two parallel lines connected by a transversal. It's that capital F shape. Whenever we see this, we know that this and this have to be congruent. So there's the start of our SAS. So we ultimately just need to compare two things, this and these two divided, and these two divided. So let's set that up. We're going to put the smaller one again on top. So 33 divided by 54, that's for this and this. And then these two is going to be 22 divided by 36. We have to ask ourselves, are they equal? So 33 divided by 54 gives us 0.61 repeating. And 22 divided by 36 gives us 0.61 repeating. So we would be able to say, yes, These are similar by side angle side similarity. All right, so this last one, objective 4, just says, if the following triangles are similar, determine which theorem. So I am actually going to leave that for you as practice. There are 9 questions there. You only got 3 choices. It's either angle, angle, side, angle, side, or side, side, side. I guess there's a 4th choice. You could also say that they are not similar. So let us know if you run into any questions on this. Best of luck. You are going to do